As you look out into the vast expanse of space and observe the shimmering lights of billions of stars, it's impossible not to feel a deep, age-old question stirring within. Are we truly alone in the universe? For generations, this mystery has captivated human imagination. Now, a powerful new instrument has been launched into orbit, the James Webb Space Telescope. This extraordinary piece of technology functions like a cosmic magnifying glass, revealing distant corners of the universe. With an unprecedented level of detail, it has already turned its gaze toward a particularly fascinating target, K2-18B, an exoplanet that has sparked major interest within the scientific community. K2-18b isn't just another distant planet. Early observations revealed something extraordinary: signs of water vapor in its atmosphere, a key element that suggests the potential for habitability. Even more intriguing was the detection of a molecule that is strongly associated with biological activity here on Earth. This discovery prompted scientists to ask a thrilling question. Could we finally be on the brink of uncovering evidence of life beyond our own planet? Let's take a closer look at K218b and explore the scientific significance and implications that could profoundly change our view of the cosmos. Positioned 120 light-years from Earth, K218b is classified as a super-Earth, falling into the sub-Neptune category. This means it's larger than Earth, but smaller than Neptune, unlike anything found in our own solar system. Its unique size and composition make it a challenge to categorize and study. Scientists often rely on familiar planets like Earth, Mars, Jupiter, or Saturn as benchmarks, but sub-Neptunes like K218b have no direct counterpart nearby, making them a true mystery. What makes K218b particularly compelling is its position within the habitable zone of its star, a red dwarf called K218. This zone is the sweet spot where conditions might allow liquid water to exist. Although K218b orbits much closer to its star than Earth does to the Sun, only 0.18 astronomical units away, which is even closer than Mercury, its host star emits far less heat. As a result, the planet avoids becoming a scorched wasteland, and instead maintains conditions that might support water in liquid form. This closer orbit also means that a year on K218b lasts just 13 Earth days. But the star's relatively low heat output has actually turned out to be an advantage. The cooler environment has allowed scientists to detect vaporized water in the planet's atmosphere, a discovery that has far-reaching implications. In addition to water vapor, the James Webb Space Telescope detected carbon dioxide, a common atmospheric gas, and methane, which breaks down quickly under solar radiation. The presence of both is noteworthy. But what truly astonished scientists was the possible detection of dimethyl sulfide, DMS. On Earth, DMS is not a molecule you'd find in the wild unless life was involved. It's produced almost exclusively by microorganisms in our oceans. So its presence in the atmosphere of K218b is deeply compelling. Red dwarf stars like K218 are known for emitting strong radiation, making their planets generally less hospitable. Yet K218b seems to defy those expectations. If its atmosphere is stable and thick enough, it could maintain temperatures suitable for liquid water, even under the intensity of its star. In fact, its hydrogen-rich atmosphere could result in oceans warmer than Earth's. The close bond between this planet and its star ensures that any surface water would not evaporate away, an important factor in the ongoing search for life. Recent studies suggest that surface water might be a defining characteristic of exoplanets like K218b. Back in 2021, a new theory emerged. Professor Niku Madhusudan, who was among the first to suggest DMS might be found on another world, introduced A new class of planets in a paper published in the Journal of Astrophysics. These planets are called Heisen Worlds, a name inspired by their mysterious nature and hydrogen-rich oceans. These planets would be nothing like the rocky bodies we're familiar with. They could have up to 10 times the mass of Earth and twice the radius, and they might reach temperatures around 200 degrees Celsius. But instead of being dry, lifeless infernos, they could host vast oceans that make up the majority of their mass, potential homes for microbial life. The thick atmospheres of these worlds would trap heat, allowing liquid water to exist at greater distances from their stars than is possible for rocky planets. Since larger planets like these are easier to detect with telescopes, they've become ideal candidates in the search for life beyond Earth. Dr. Madhusudan's team has used the James Webb Space Telescope to closely study K2-18B, aiming to understand this alien world in greater depth. However, identifying ocean planets with even the most advanced instruments remains a major challenge. The real key to unlocking K218B's secrets lies in how it's observed. A total of 5 hours of observation were planned, divided into 2 sessions, to make use of a rare celestial event, a transit. During a transit, the planet passes directly between us and its star, allowing the telescope to capture starlight that filters through the planet's atmosphere. This light holds a wealth of information. As it passes through atmospheric gases, certain wavelengths get absorbed, leaving behind a fingerprint that tells scientists exactly what elements are present. By splitting this light into a spectrum, much like a prism turning white light into a rainbow, researchers can identify these atmospheric components with incredible precision. Missing wavelengths reveal the presence of specific molecules and allow scientists to build a detailed picture of the planet's atmosphere and potential for life. K2-18B continues to capture the attention of astronomers and researchers around the world. The more we learn about this mysterious world, the closer we may come to answering one of humanity's most profound questions. Are we alone in the universe?